All right. First thing, if you were gone last week, because I know we had a lot of people gone for different things, you are missing the 6.2 homework quiz. We also did the 6.3 notes and homework. Okay? So 6.2, 6.3, you need to make that up. The 6.4 FRQ. All right? It's there if you want to look over it. I'm going to make a video today after school where I talk about it. But if you don't want to do it, don't do it. All right? I do think it's good practice. It's good FRQ practice for your test and for the AP test. I'm not going to take it up with the homework packet, and I'm not going to take it up for a grade. Okay? So if you feel really overwhelmed with everything else that you have going on, and you just want to throw away 6.4, that's fine. We will talk a lot more about FRQs when we get closer to the AP test. All right. But 6.2 homework quiz and the 6.3 homework you need to have and you need to do, and you need to make sure you watch the video and you do the notes and you know how to do all of that. The 6.3 quiz we are also not going to do today because I want to spend more time on the related rates notes that we have. I want to be able to take it slow and give you time to practice in class, because I think once you start doing it, that's when it starts clicking. All right, but if you just watch me do it, you're going to be confused. So you need to practice it. It's one of those things that you're going to have to practice. We're doing related rates today and tomorrow. All right, so we have 2 days for related rates. Today is kind of the easier day. Tomorrow we add a couple more concepts to it. So it's important that you get a decent understanding of what's happening today so you're not lost tomorrow. All right, so we have more time. We're not going to do the 6.3 quiz. We did it in fourth period and I didn't like it. All right, we've already kind of talked about that stuff. It wasn't really a beneficial quiz. So we're going to just move on from that. And we're going to do the notes. Now, if you look at your notes, I messed up. I messed up on the labeling. So on the solving related rates, that is supposed to say 6.5, not 6.4. All right, so I messed up labeling the lessons. And then if you look at where it says solving related rates, missing values and cones, that is supposed to say 6.6, not 6.5. Okay, and then we should be good as far as the labeling of everything. So close, but we did not get a 6.7. All right. So let's talk about what related rates are. We are going to talk about real life scenarios. And in real life, we have variables that have familiar relationships. In other words, we're going to have variables that are going to relate to each other. And a lot of the formulas that we're going to use are formulas that you learned back in geometry. So this is where kind of geometry and calculus kind of marry each other. And it's just kind of cool.
I wasn't good at that geometry stuff. Okay, we did a lesson.
All right. So a great example of this is Pythagorean theorem. A squared plus b squared equals c squared. So let's say a triangle's dimensions are changing. That means the dimensions a, b, and c are changing. And so a, b, and c are going to have a rate of change. Since they are not staying the same, they are not constant. And this rate is going to be related to the other values in the formula. And so when you differentiate your variables, you have to differentiate in terms of time, because we are talking about this in a real life scenario. So instead of putting dy dx after every single y term, you're going to put dy dt. And when you differentiate an x term, you're going to put dx dt, and so on and so forth. So anything that is a variable is going to get d whatever dt. All right, so let's look here at 20. A squared plus b squared equals c squared. We're going to differentiate this. So what is the derivative of a squared? 2a, and then I've got to put dA dt. Plus, what's the derivative of b squared?
2b, db, dt.
Yep. Equals, what's the derivative of c squared?
2c.
dc dt. And that's my derivative. All right, go to 21. Now on 21, my variables are A and R. Pi is a constant. Pi is 3.14. It is not changing. It is always going to be 3.14. So you don't have to use product rule on this one because pi is a constant. A and R are the variables. Now what's the derivative of A?
1.
1 times
d/dt.
d/dt. So you don't have to put the 1. If you want to, you can. But the d/dt is important. So if you want to put the understood 1 in the front, you can.
2 pi r dA minus dr dt.
Yes, very good. And then for the pi r squared, you're going to power rule that. 2 goes in the front, minus 1 from the exponent, times by dr dt because it is an r term. All right, and so 22. On this one, my variables are v, r, and h. So v, r, and h are all changing. R and h are multiplying by each other, so what rule would you have to use? Product rule. All right, what's the derivative of v? dv/dt. Equals. All right, so I've got first function, second function. So for product rule, we are going to write the first function. Totally normal. Do not change it. Times by the derivative of the second, which is dh/dt, plus the second function, totally normal, times by dr/dt. He say it. All right, so let's look at your homework now.
This is plugging children's special. Can I explain myself on that?
All right.
I tried to skip it on the desk. Why? Just hit him in the head. I didn't want to hit him in the head. What do you think I didn't throw it earlier? Hit him in the head. He said it.
All right, on your homework, we are going to do number 3. On number 3, I forgot to give you the value of z. The value of z is 5. On the homework. Homework. No, we're not done with the notes, but we're going to take a little break and do some homework. All right, so we will not finish if y'all are going to keep talking. Number 3 says if x squared plus y squared equals z squared, find dy dt when x is 3, z is 5, y is 4, dx dt is -1, and dz dt is 5. All right, so I'm given my formula right here. I need to take the derivative of this guy in terms of time. So what's the derivative of x squared? Times dx dt plus
2y
times
dy
dy dt equals
2z
dz dt. All right, now on this problem, we are trying to find dy dt. Knowing what you're looking for is super important. So dy dt is the only thing that should stay in here as a variable. Everything else should be replaced by a number. All right, so when I go through this, what is x going to be?
3.
What is dx dt?
-1.
Plus, what is y?
4.
dy dt can stay dy dt because that's what I'm looking for. What is z? 5. And dz dt is also 5. And so now that everything has a number, we should be able to solve for dy dt.
Oh, I didn't see this thing that she wrote at the top.
Yeah. So -6 plus 8 dy dt equals 50.
We gotta add the 6,
Mm-hmm.
56 divided by 8, which is 7, so dy dt equals 7.
Perfect.
Kid knows.
All right. Does that make sense how to do those, guys?
Yes.
I'm going to give you like 2 minutes to try either 1, 2, or 4.
We have to.
Yes, like 2 minutes, try it, and then we're moving on to something else.
Yes. Wait.
Trey, so
What are we doing?
Trey, you're being so serious.
1, 2, or 4,
serious.
or whatever you can finish in 2 minutes.
1, 2, or 4. Let's do number 1.
One's gotta be the easiest, right?
Sure.
Alright, 12x cubed y t equals 6 dx dt. Okay. Wait.
So 12. 12 times negative 36
plus 6
plus negative 18.
You get negative 18. You gotta take the derivative of 6x.
Yes, 6.
It's 6.
So where'd you get the negative 18?
dx dt.
Where did you
I'm
get
sorry, but what? Everybody else in this room is in agreement with me. No!
That's
That's
negative 3.
Because it's an extra.
Did you still do that?
Yes.
Oh, you're
Anytime you take the derivative of an x.
Where'd you get that from? The entire room thinks it's that. What? Negative 18? 30 something? Negative 36 plus negative 18. What is that? Negative 54.
Oh,
Negative 54. So dy dt goes negative 54.
Trey just said 6-7, mind you.
Let me
I think Aiden deserves to throw it instead of.
Nope, that's not the rule.
Stupidity should be a rule.
You say that. Well,
It
then
really
you would have had a lot
No,
whenever
it
you
really
said, "What's the
should."
biggest number?"
Like 100 trillion.
100 billion.
Like y'all would have thought of a million or
It's not even
I would have
billion.
immediately thought of infinity.
Everyone thought it was
You know
infinity.
what? Boom!
Oh, what's the
Whoa.
Whoa,
Whoa.
whoa.
Wait, so Trey, you're being serious, right? About Alyssa? Like it was
Okay,
just a
here's
lucky.
what happened.
I guess.
She
By the way.
talked to me first.
I don't care what happened.
What happened?
Is this
That's
true?
really not even like.
I don't care how it
All Wesley
started.
said it was that she said hi to you in the
She
hall.
did, and I wasn't.
And I
expecting
straight grabbed that rebound and hunked it down outlet pass, and we're slamming it home for 2.
Alright, stop with the.
That was a bad analogy.
Yes.
And that was a terrible
I'm
analogy.
just saying.
I'm not gonna lie, I was not expecting it.
Okay,
When she said hi, I was just like walking to class.
we are moving on.
Alright, Susan.
All right. I don't know what we're talking. I don't know. Okay.
I'm gonna throw something at you because your analogy was awful.
No, that's not the rule.
Oh my god.
Did I hit you in the eye?
Yes.
Headshot.
Yep, email David. Email David.
Ow! Ow! My eye!
What's a little salt without a little pepper?
That was a good one, John.
That was pretty good.
Oh my
Are we
eye!
serious?
I support that.
Alrighty. Here's what we're gonna do. We're gonna see. So far, the classes have been marginal at this. I have this situation because now we're going to be applying rates to real life scenarios. So I have this ladder and it's leaning against my wall, and I'm going to pull my ladder at a constant speed of 3 feet per second along the bottom of the ground. So the bottom of the ladder is moving at 3 feet per second. Does that make sense? The whole time. I want to know how fast is the top of the ladder moving down the wall if the bottom of the ladder is moving at a constant speed of 3 feet per second. Does that make sense? So the bottom of the ladder is moving at 3 feet per second.
What's the ladder moving? You got legs now?
No, I'm going to move it. I'm going to take it from the bottom and I'm going to
So
pull
you're
it.
moving the ladder.
I'm moving the ladder, yes.
The ladder isn't moving itself.
No.
Okay.
I'm moving the ladder at 3 feet per second on the bottom. How fast is the top moving? Down the wall. If I pull the bottom at 3 feet per second, how fast is the
I
top
would
moving?
hope 3 feet per second.
Okay, so what we're going to do to kind of figure this out, because the bottom is going to move at a constant speed, right? You see this little dot right here? Every time it hits a number, I want y'all to clap. Okay?
Oh no.
All right? So as it hits a number, you're going to clap, okay? Does that make sense? Is everybody ready?
Get ready for your snap.
One clap for every
I see your snap
number.
count.
All right? One clap for every number. Are you ready?
All right, watch it.
All right. 5, 4, 3, 2, 1. Oh, wait, hold on. I meant to.
Might have just fell on you.
All right, we're gonna. I meant to move it slower. Are you ready? Let's try that again. All right, ready, set, go. Clap, clap.
It's really odd.
That was really bad. Okay, let me slow it down a little bit more. Let's
move at a good speed.
let's see if we can do a
The play
speed.
clock's at 5.
All right, are you ready? All right,
Mr. What pacing are you on?
the bottom of the ladder.
It's not even
Let's go.
Why are y'all so bad at clapping?
It's a half markers.
You clapped 4 times before it even got to 1.
Oh, I bet mine's lagging.
It is. It's like
Oh, okay. I see. It said I'm recording. Okay, you're right. It's bad. All right.
Have you now?
I will agree that one is not your fault because it's lagging because I'm recording. But
Is that the board?
there we go.
Trey, when did you have this change of heart? Boy, this is in the recording.
All right, we're gonna try it. We're gonna see what happens. I don't know what is gonna happen with the lag, but we're gonna do it on the y-axis now. Are you ready to clap?
Yes.
Okay. All right, we're clapping when the top hits the numbers here.
Okay.
All right, whatever.
Thank you.
Yeah. All right, the point is, this guy here is speeding up. That guy there was moving at a constant speed. Yeah, it closed out. My iPad's not liking me right now. Everything's closing.
Can't do the lessons today.
No, we can't. We're still doing it.
Why is there a QR code?
That's what brings you to the ladder.
We can't do our.
Because last year you could have phones, and so we could log into GeoGebra and play with it.
Yeah, this year.
All right. All right, so let's try an example. So the point is, the ladder, as it was falling, it moved at it sped up as it fell. All right, so it wasn't constant, even though the bottom was constant, which works out if I'm not recording and the screen isn't lagging, but it is what it is. All right, let's try an actual example. So I have a rectangle, and its width is increasing at a rate of 2 centimeters per second. So I'm going to draw a rectangle. And the width of this rectangle is increasing. So I'm going to draw an arrow to represent increasing because it's not staying the same. It's increasing at 2 centimeters per second. And the length is increasing at 3 centimeters per second. And I want to know what the rate of the area of the rectangle is increasing at when the width is 4 and the length is 5.
20?
That would be the area, but I want to know the rate. All right, so
Right is the area.
nope.
That's what it says.
What rate is the area of the rectangle increasing?
Yeah, goofball.
All right, so let's talk about what we're trying to find. If you're asking about a rate or how something is changing, that's one of your DTs. So if I want to know at what rate the area is increasing, I'm looking for dAdt. All right, so the thing that I'm trying to figure out is dAdt. And it is very important that you can look at a problem and be like, I'm looking for whatever. That's the number one question I'll ask you if you're stuck. Do you know what you're trying to find? Because a lot of people will have a picture and they don't even know what they're looking for. They don't even know what they're trying to find. So on this one, the rate the area is increasing is dAdt. If it asks for what is the area, 20 would be correct. But it's the rate the area is increasing. So it's how the area is changing. Does that make sense? Yeah. Okay. So what is the formula that is relating length, width, and area? What's the formula for a rectangle?
Width times length.
Length times width. So area equals length times width. Now remember, everything's changing. Length is changing, width is changing, area is changing. Do not plug in yet. That's what everybody tries to do is they get a formula, they start trying to plug in stuff. Do not plug in yet. You have to take the derivative. All right, we have to take the derivative before you can plug in. All right, so what is the derivative of A? dA dt. What rule do you have to use for L times W? Product rule. So L, derivative of the second, which is dW dt, plus the second, which is just W, and the derivative of the first, which is dL dt.
What did I do? What did you do?
All right, hold on, focus. If y'all aren't focused, you're going to lose it. And we're doing this today and tomorrow, and it's on the FRQs of your test. You'll be screwed if you don't know how to do it. All right, so when you're doing product rule, first function, derivative of the second, plus the second function, derivative of the first. From here, you should be able to plug everything in except for what you're trying to find. We're trying to figure out what dA dt is. So dA dt can stay in there. We don't know what it is. That's the whole point of this problem, but we should have a value for everything else. So what is L going to be? 5. dW dt is how the width is changing. 2. Plus, what is the width?
4.
And dL dt is how the length is changing. 3. And then when you plug all of that in your calculator, you get 22. What are my units? Centimeters. What's the unit for area? Centimeters squared per second. Now, why is it centimeters squared and not just centimeters? Area. What would volume be? Cubed. And the regular length would just be centimeters. Now, is seconds squared? No, because it's the first derivative. So seconds is just seconds. It's the first derivative. Centimeters is squared because we're talking about area. Okay, let's try another one. They're circles in circles. All right, so here's my picture. I have a pebble. It's dropped into a pond, and it's causing ripples. And so ripples look like circles in circles. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. So the radius is getting bigger by 1 foot per second. When the radius is 4 feet, so when the radius is actually r equals 4. At what rate is the total area of the disturbed water changing? So there's my question. What is the rate the total area of this disturbed water is changing at? What am I looking for? The rate the area is changing. So I'm looking for dA dt again.
I wanted to say that, but I didn't think we would do it twice in a row.
All right, so we got to come up with a formula. What represents the area for a circle? Pi r squared. Now, don't plug in numbers. You have to take the derivative. So what's the derivative of A? dA dt. What's the derivative of pi r squared?
2 pi r
dr dt. All right, now we're going to plug in what we know. So we are looking for dA dt. So that can stay dA dt. What is r going to be? 4. And what is dr dt? 1. So the area is changing at 8 pi. What are my units? Close.
feet squared.
Feet squared per second, because we're talking about area again. So it should be squared. All right, let's try the next one, a triangle example. All right, I have a ladder. It's 20 feet long, and it's leaning against the wall of a house. The base of the ladder is being pulled away from the wall at a rate of 4 feet per second. How fast is the top moving down the wall when the top of the ladder is 12 feet above the ground and the base is 16 from the bottom of the wall? All right, we need some variables here because it's not giving me R and area and things like that. So what do you want to label the sides of this triangle?
H, no.
It doesn't really matter.
X and Y.
Oh, I just did A, B, and C. Can I do A, B, and C?
Yeah, it's fine.
Let's do A, B, and C.
Okay. All right, so C is going to be 20. The base of the ladder is being pulled away at a rate of 4 feet per second. So this guy here is changing at a rate of 4 feet per second. I want to know how fast is the top of the ladder moving down the wall. So what am I looking for? What variable is representing that length?
DA?
DADT, yeah.
I knew it, dude.
So we're looking for DADT. It's how fast, so we're talking about a rate, and the length that represents the wall length is A. So we're looking for DADT when the ladder is 12 feet above the ground, so when A is 12 and it's 16 away from the wall, so B is 16. Now, what formula is relating all of these variables together? Yep.
Attaboy.
A squared plus B squared equals C squared. Now, can you plug stuff in? No, what do you got to do? Derivative. So dA dt plus 2b dB dt equals 2c dc dt. All right, is that okay so far?
Yep.
Now, you should have a variable for everything except for what we're trying to find. What are we trying to find? DADT. So everything else should have a number we can plug in. What am I going to plug in for A?
12.
12. We don't know DADT. Plus, what are you going to plug in for B?
16.
16. What am I going to plug in for DBDT? 4. What are you going to plug in for C?
20.
And what are we going to plug in for DCDT? How is the ladder changing?
4 feet. Negative.
No.
0.
0. Why 0?
Because it's going to go to a stop, right? Or,
Is the length of the ladder changing? No.
Lucky guess.
Right.
No.
well, I knew it was 0. I just didn't know why, honestly. I couldn't.
So if something is not changing, does it have a rate? No. So the ladder is not getting longer or shorter. The ladder is not changing.
Cancels out, right?
C equals
So-
0.
Yep. So all of this is going to go away and be 0.
What's 2 times 16?
All right. So 24
16 times 4 first.
DADT plus 128 equals 0. Minus 28 and divide by 24 is going to give you negative 5.333. All right, let's talk about units.
How do we get negative? Oh, never mind. I know how we got negative.
Minus the 128.
Negative 5.33.
What are the units for DADT?
Feet squared per second.
Feet per second.
Second squared. Feet per second.
Feet per second.
Oh.
Just throwing up hands.
All right, think about
So are you.
what does, listen. What does A stand for? Is it an area, is it a volume, or is it a length?
Length.
It's a length, so it's just feet. And then the time is seconds. It's not the second derivative, it is the first derivative. Now, why is the rate negative?
Because it's going down.
It's going down, yeah. Your little ladder's falling down, and so the length of that wall is getting smaller. So the rate makes sense for it to be negative. All right,
Drop something.
look at the 27. I don't know if I have time for 26. Maybe I do. I lied. Nope, I want to do 27. Nope, I'm going to do 20. I lied. I want to do 26. Shh, 26. Sorry. We're going to do the cylinder. But I need y'all to focus so I can finish it. All right. I have a tanker accident that spilled oil. So it's kind of like, pretend like you have your water and you spilled water on your desk. It makes a cylinder. It's just a really, really small height.
Looks like a Subway sandwich.
It's like a pickle. That looks like a Subway sandwich to you? It's like a hockey puck.
Yeah, that's what it, kind of like a hockey puck. All right, so it's really, really thin. All right, if you spilled water on your desk, it'd be like a really, really thin cylinder. The oil-eating bacteria is gobbling it at 5 feet cubed per hour. So let's talk about this number right here. What does 5 feet cubed per hour stand for? Volume. And since it's per hour, it is dVdt, because it's the rate. And since it's gobbling it, what else is special about the volume?
He's gobbling, man.
What else is special about it?
It's a derivative.
No.
It's the answer.
No. It's negative.
Oh, sure. That's what I was thinking.
Okay, does that make sense so far? So if something is cubed, it's volume. If something is squared, it's area. The oil slick has the form of a cylinder with the radius of the cylinder being 500 feet.
Gosh.
All right, so the radius is 500 feet. The thickness or the height is going to be 0.01. And the height is decreasing. All right, so the height is getting smaller. So since it's decreasing, it's going to be negative at 0.001 feet per hour. Now, what does negative 0.001 feet per hour stand for? What is decreasing?
The height.
The height. So that's going to be what? dH/dt. All right, and so the question says, at what rate is the area of the slick changing at this time? So what are we looking for? dA/dt. Mm-hmm.
Yep. Yes.
All right, and so then there's one other piece of information that I forgot to give you on this problem, and it is what the area actually equals at this time, and it's going to be, and you can find it, but we're going to talk about that tomorrow, but 250,000 pi. All right, so I have area, I have volume, I have R, I have stuff about H. So normally if you're going to find area, you would write your formula as pi r squared, right?
Yes.
But do you know anything about dr dt? No. So pi r squared is not going to work because you don't know anything about dr dt. So we're going to write a different formula for a cylinder. We're going to write the formula for volume because I know what volume is. What would be the formula for volume of a cylinder?
R times H.
Pi r squared times H. All right, now, shh. Once again, we don't know anything about dr dt. So what is another way I can represent pi r squared?
The derivative.
No, what does pi r squared equal? I wrote it over here.
Area.
Area.
Oh, the area is 250,000 pi.
Well, hold on, we're not plugging in yet. We're just going to write it as A.
Plug in, you do derivative.
We're trying to come up with a formula that relates the information that I'm given. I don't know anything about dr dt, so I don't want R in my formula.
We gotta do product and all that.
Mm-hmm.
We take derivative of this.
Yep. So I know stuff about A, I know stuff about H, and I know stuff about V. So this formula is good. So, yep, so we're going to do product rule. So dV dt is going to be 1 d2 plus 2 d1. So A times dH dt plus H times dA dt. Now, once again, what are we looking for? dA dt. We should be able to fill in stuff for everything else.
250,000 pi.
All right, so what are we going to put in the spot for dV dt?
Negative 5.
-5. What are we going to put in the spot of A?
250,000.
250,000 pi. What is dH dt?
Negative 0.001.
Plus, what is H?
0.01.
0.01. And we are looking for dA dt. And so then from here, you would be able to solve for dA dt, which would give you 78,039.816.
I would use the oh no, I see how I lost the negative.
What are my units?
What is it? 78.
They gotta cube it. P cubed hour.
Feet cubed?
It's volume, right?
D-A-D-T.
Oh, so it's squares.
Feet squared per
Hour.
hour.
You almost wrote second.
I did.
What?
All right, since the area is changing at 78,000 and 39.8186, is the area increasing or decreasing?
Increase.
Why?
It's plus and positive.
Yep. Increasing because DADT
That's y'all's band.
is positive.
That's y'all's version of PTV bands. 14 to win.
Okay.
Yeah, we don't win.
I don't think I have time for example 27. If you want to look at it, it is going to be on the notes key that's posted. But tomorrow you are going to have a homework quiz. You need to practice your homework. This stuff does take practice. You've got like 15 minutes. So if I were you, I would start doing the homework. I would maybe check out the first one. You are going to have on your homework quiz tomorrow, which I'm going to set a timer because we can't spend forever on the homework quiz. You either know it or you don't. You're going to have a cube.
Yikes.
You're going to have a triangle. You either know how to do it or you don't. So do your homework. I am telling you what's going to be on your homework quiz. Do the cube one. Do a triangle problem. On your homework.
The lighters are triangle ones, correct?
Yes. The only other one that I think I forgot to give you a piece of information is 9A. I forgot to tell you that the radius is 3 inches. There is a way to find it, but we haven't really talked about that yet. So for 9A, make a little note to yourself. If you're looking for radius, it's 3 inches. All right, I think everything else is good to go. I'll be here in the morning if you need help.